Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hello, welcome back to this amazing channel. This is Abhinav, and today we are back with our next problem of the day, which is nothing but permutations of a given string. So, yeah, guys, the problem today is very common. It's not much hard, it's not much easy because it's a very common problem. Like, whenever we start with recursion, we do this problem called permutations of a given string. So, that's a very classical problem we have today. Before starting, please let me know if I'm clearly audible and visible to you all, guys, so that we can start our today's class. Hi, Risit. Hi, how are you? Uh, Great. So let's start with today's class, I guess. Okay. Yeah, great. So amazing. Let me share the screen of mine. I hope that the screen is also now visible to you all. The problem is very simple, that for a given string we have to find and return them in a sorted order, actually in lexicographically sorted order. Like, let's say if we have ABC. Okay, so permutations can be ABC itself, it can be ACB, then it can be A, like not A, it can be BAC, or it can be BCA, it can be CAB, it can be CBA. Okay, so I will tell you that how actually this thing actually happens. Okay, so let's say this is A, B, and C. Okay, this is A, B, and C. So like we will give indexing to this string. This is 0, 1, and 2. Okay, so guys, what happens is that we take a L. So L is the start point, and R is the end point of the string that we are currently considering. I'm not saying it is the start point and end point of a string. It's the string that we're currently considering. Okay. Now what we do, guys, that we start a I. So I starts from L, goes up to R, and for every I, we swap that I with R. And for every such a condition, we take a different recursion call. So like currently, let's say I is here. So a different recursion call will be done where this and this will be swapped. So it will become C, B, A. Okay. Then next call will be when I will be here. I will be here. So now B and C will be swapped. So it will be like A, C, B. Next call will be when I will be here. So like they will not be like I and R at same place. So we have to basically swap I and R. Okay. So now at this particular point, it will be like simply like we can swap I and R also, or we can also swap I and L. So like where people prefer it. So like if you want, you can swap I and L also. That's also fine. Like let's say I start from here. Okay. So first of all, what you will do is like next permutation is an inbuilt function, but I will not use next permutation function because in Java we don't have such type of function. So I will write the whole code. Okay. So like you have to swap you have to swap like if this is S, so you have to swap S of L with s of I. Okay, so like here in this particular case it will be same a, b and c. Now when I will be at index number 1, then it will be like swapping these two, so it will be like b, a, c. At the last, when I will be at last index like r, so it will be like c, b, a. Now for the next recursion call, my L will be here. So my L increases until it reaches R. So my L increases. Okay. Now we will do the same for this. So like one where no swapping is done and another where swapping is done. Just like here. So guys, this is how we got our final answer. So whenever like in this case you can see your L and R will be same. So whenever your L and R will become equal, you will use that answer, you will store that answer in your respective like vector or something that you want. Okay. So if you will see here, what I will do, I will simply write this permutation function. Okay. So we will write a separate function for it because it's a recursive function. And as we have to store it in a vector, so I will first of all have a vector here. So I will have a vector here. Let's say vector answer. Okay. I will have a function, let's say permute. Okay. So this function will have basic three things. First thing is that string s itself. Then will we have L and R, as I told to you. So this is L and this is R. So we start from L and R. So like if L and R are equal, so you can see at the last, the case of this recursion is that if L and R are equal, like you can see in this particular case, the last case, L and R are equal. So if they are equal, what we will do? We will be pushing that string, whatever the string is, we'll push back that string s in that answer. Okay, that is the basic thing that we are doing. Okay, great. Now the recursive case. So now guys, the recursive case says that you have to take a value of I, and I should iterate from L to R, and for every I you have to swap it with L. Okay, so like you will take a for loop for I, it starts from L, goes up to R. And every time you will perform a swapping of S of I with S of L. And after swapping, like let's say I is here. Okay, let's say I is here. So like you swap these two things. You swap this one with B. So it becomes B and A after swapping. Okay, it becomes B and A. And now you have to again call for recursion, but L will be increased. So L will now be here. So now L will be increased one. So like you will have again a recursion call of permute, but this time your L will be increased. R will be as it is. This is how your L will increase. And guys, we will also backtrack here. Why backtrack? Because you are swapping, you are making changes in that S. But that changes will be just for this recursion call. Got it? You see, like when we are swapping this A and B, that is just for this recursion call. It's not for the next one. You have to again backtrack it the previous one. For that, you will again swap it. You will again swap it, it will remain same. Okay. Now at the last, what you will do? At the last, you have to simply call this permute function, and you have to also sort that answer array, because what they want is they want your answer in lexicographically sorted order. Okay, so you have to sort it, and then you can simply return your answer vector. Okay, so it is a very classic problem, guys. Okay, if you see, you will find this problem very easily. Okay, because it's a really classic one. Okay, so whenever you learn about recursion, or I will say more preferably backtracking, we for sure take this problem. So initially the value of L will be 0 and R will be n minus 1. Like L will be at the first index and R will be at the last index. Okay, so that is our initial value of these things. So it will be n minus 1, like length minus 1, and the string itself. Okay. So I guess now it's completely fine. We can now submit it. Okay, so okay, there's one more thing, guys. Yeah, I just missed this thing. That we can also like have a kind of repeated like things. We can also have repeated like you can see that when we have A, B, B. So and I think that they wanted us just the unique values now. Yeah, so they don't want from us the repeated value. So for that, what I will prefer is I will prefer having a set. Okay, then I will prefer having a set, and I will store these values in that set. So I will store these values in a set so that it should become unique also and sorted also. Okay, so I will have a set st. Okay, I will store that values in a set, and after storing that values in a set, I will again move them back to the answer. So I will have this string answer here. Now I will simply iterate through that set st. Okay, I will simply iterate through that set st, and then I will push every string inside this answer. So because we are taking a set, it should be okay. Okay, we want a return also. Exactly, guys. Thanks for it. By the way, that is not required because okay, it was required. I guess it was required. Yeah, there should be a return at line number 13. Thanks for it. Yeah, so now we solved it. So we are taking a set because we want unique plus sorted. So unique plus sorted means we all know that it is a set that we take. Okay. So like this is how we solve this particular problem, which is permutation. You can see this is a time complexity. So it is the you will say that what is n factorial. So see guys, it's something like how many times this function will run. This function will run number of times equal to how many permutations are there. So if there's a number n, so if I will ask you that if there's a number n, like if there's a string of size n, so how many permutations will be there? You will simply say that there are n model n factor permutations of a number n. So if number is like, let's say there's a string of size 3, you have just seen that we have 6 permutations of it. So like for a string of size 3, we have n modulus n factorial permutation. So like that recursion call will run n factorial time, and each time it is taking n. Why? Because each time you can see it is a for loop from L to R. So overall, this is the time is complexity, and if you will consider recursive stack also, so that the same will be the the same will be the, I can say, the space complexity too. Okay, yeah. So I hope it is fine. Hi Lakshman, hi guys. So okay, so like is it completely clear to you guys? Okay, सबको clear है? Fine, just write a +1 if it is clear. Like Rishit, as you can see that there's a backtracking. Okay, like there is something after every recursion call. Okay, there's a backtracking, and backtracking uses recursive stack. So the space complex is n factorial if you will consider recursive stack, because there are n factorial recursion call. If you will see, there are n factorial recursion call. Okay, yeah, exactly. It is for that stack only, for the permutation. Okay, fine. For that also, okay. Sorry, my bad. So obviously, yeah, like we have to also consider this thing, this set, or I can say this array, this vector, which we are using to store. I guess that's also fine, yeah. But that's a very obvious thing. Like it's not extra space that we're using. If you will see, it's simply something that we're using for storing the answer. Okay, so we mostly don't consider it as that like time complexity thing. Like let's say they can ask you to print it also instead of storing, but yeah, uh, I can say that yeah, that n factorial is because we have to store that factorials also. How to get SD intern into link? Like you can just check out if there's any opening for internship at GFG. Sorry, for GFG. Okay, yeah, GFG. So like we can just simply check out the careers portal of GFG on the website, and if there's any opening, you can apply. That's the only way. Apart from that, you can like be active on platforms like LinkedIn. You can connect to recruiters at GFG. That's the only way, I guess. Okay. Yeah. So thanks guys. Thanks for this class. Let's meet again tomorrow with a new POD. Till then, thank you. Happy coding. Bye bye. टेक केयर जीएफजी कर लो हो जाएगा